Hi, everyone. I'm sure you missed me yesterday, and I'm sure you're missing me today. But I figured this would be the easiest way, pardon me, for us to take notes. So, today we're going to talk about factoring, and it's been on your weekly reviews, and I know you've been so diligent about them, so this should be an easy notes day. There's three ways to solve quadratics when you're asked to solve. The first one that we're going to talk about is factoring, and there's kind of rule of thumbs on how to factor. So if you don't have your notes out by now, get them out because you're writing this down with me. First thing you need to do, always check if there is a GCF. What does a GCF stand for? Ah, yes, the greatest common factor. You always need to factor out the greatest common factor. Why? Because it's going to make your numbers smaller and it's going to make it a lot easier to deal with. The second thing that you need to check for is if there are special patterns. So you want to look for any special patterns. And special patterns are things that you've seen before. The first one would be a difference of squares. Okay, so that's the first type of special pattern that we'll see. Difference of squares would be, for example, if you had x squared minus 81 is equal to 0. So difference being subtraction, and then squares, well, both of your terms are perfect squares. So they factor to be x minus 9, and then x plus 9 is equal to 0. Okay, so those are a difference of squares. Another example for a difference of squares would be, if we had, let's say, 4x squared minus 16. Okay, 4x squared, well, that is 2x, and then minus 4, and then you can say 2x plus 4, set it equal to 0, and then you can solve from there. The second special pattern, this one we're not as prone to recognizing, is called a perfect square trinomial. And I'm just going to give you guys one example for that. The perfect square trinomial is, let's say that we had x squared plus, we'll do 18x plus 81. Well, if you try to figure out what two numbers multiply to 81 but add to 18, you're going to end up with the same binomial being multiplied to itself. And that's what we call a perfect square. So if you have the same binomial multiplied to itself. Okay, step 3. Remember, we're talking about how to factor. Step 3, once you've identified if there's a GCF, if there are special patterns, the third thing is just to factor. And then the fourth step is to ask yourself, can I factor any further? You need to keep factoring. Keep factoring until you can't factor anymore. Can't factor. Ugh, this pencil. Oh my goodness. Sorry, guys. Okay, so can't factor anymore. And I guess I should say sorry to my husband who's holding the phone to video record. Thanks, honey. Okay, so let's do a couple examples. All right, example number 1, we are asked to solve by factoring. Now, if you're going to be asked to solve by factoring, it has to be equal to what? Anybody? Anybody? Oh, yes, it has to be equal to 0. So if we have x squared plus 8x plus 15 is equal to 0. Well, nice thing is it's already set equal to 0. Okay, there's two methods I'm going to show you for factoring trinomials. If neither one of them work for you and there's another method you know, that's fine. Use that. Okay, but these are just the two that I'm going to show you. The first one's called the x factor. Okay, so this is method number 1. You need to create an x. Now, remember we discussed that your coefficients, a, b, and c, will always be given to you when you're in standard form. Well, for the x factor, you need to take a times c and put it at the top of the x. So for us, that's 1 times 15, and that's 15. And then b, you put at the bottom of the x. So for us, that's 8. Okay, so again, a times c at the top, b at the bottom. You then have to ask yourself, what multiplies to 15 but adds to 8? Okay, that's the challenge when you're asked to factor. In this case, it's going to be 5 and 3. Okay, next step. Since these add to that middle term, you're going to take those two factors and substitute them in for that middle term. Okay, so again, we just found the two numbers and plugged them in for that middle term. Then you factor by grouping. So I'm going to group the first two, group the second. Find the greatest common factor of the first. In this case, it's x. And that leaves you with x plus 5. And then find the greatest common factor of the second, and that's 3. And that leaves you with x plus 5. When you factor by grouping, these are always going to be the same. So we factor those out. And what's left over is x plus 3. Now, the big thing when you're asked to solve is you have to figure out what x is. Well, if you multiply two numbers together and they equal 0, one of them has to be 0. So your next step is that you're going to set each of the factors equal to 0 and solve for x. So x is going to be -5 and x is going to be -3. Make sure that you write them together. So important. If you're forgetful, put that on your note guide. You must write your answers together. Okay, so that's method number 1. Method number 2 is what's called the box method. And this seems to be the favored method. Again, find something that works for you and stick with it. Okay, so I'll put a big or. Well, for the box method, you still have to make that x. You're still going to take a times c at the top, which was 15, and put b at the bottom, which was 8. You still have to figure out what two numbers multiply to 15 but add to 8. For us, again, that's 5 and 3. Okay, here's where it differs. So you make a box, and this box has 4 squares. In the upper left-hand square, you put that first term. Okay, so we get x squared. In the bottom right, you put your last term. For us, that's 15. So that never changes. What does change is what goes in these two squares. It doesn't matter what order you put them in. You just have to put in the numbers that multiplied to the top and added to the bottom. Okay, again, it doesn't matter what order. Once you have them fit in, you're going to look at the columns and the rows individually. So if I look at this column, what's their greatest common factor? It's a +3. And if I look at the other column, what's their greatest common factor? It's just x. So now looking at the rows, what's their greatest common factor? It's just x. And the bottom row, it's a +5. Well, what have you done? You found your factors. So we now have x plus 3 times x plus 5 equal to 0. And we're right where we left off. So we take each of the factors and set them equal to 0. And you get x is equal to -3 and -5. Okay, so two different methods, the x factor and the box method. Okay, let's do another one. I'm going to do it with you guys. We're going to do 2 more, and then I will let you get to your assignment. Okay, so example number 2, directions are still the same. You're being asked to solve by factoring. And we're asked to solve x squared minus 13x plus 30 is equal to 0. Okay, I'm going to use both methods for you so you can see it again. The first one was the x factor. We create that x. We take a times c at the top. So that's 1 times 30. And we get 30. You put your b at the bottom. So that's -13. So this one's a little bit trickier because you have to multiply to a positive and add to a negative. Well, what multiplies to a +30 but adds to a -13? Well, in this case, it's -10 and -3. Okay, remember, they add to a -13, so we're going to plug them in. So we get x squared minus 10x minus 3x plus 30. What do we do once we plug them in? Ah, yes, factor by grouping. And pull out the greatest common factor. So for our first two terms, it's x, and that leaves us with x minus 10. For the second, the leading term is negative. So whatever your GCF is, pull it out in a negative form. And in this case, it'll be -3. And that leaves us with x minus 10 is equal to 0. These two are the same, which is exactly what we wanted. So we get x minus 10 times x minus 3 is equal to 0. Remember, if you're multiplying, two terms and they're equal to 0, one of them's got to be 0. So set them each equal to 0. And x is 10 or 3. Okay, that was method number 1. Method number 2 is our box method. Okay, we started out the same way. A times C at the top, which is 30, B at the bottom, which is negative 13. We have to figure out what multiplies to a positive 30 but adds to a negative 13. In this case, it's negative 10 and negative 3. Hey, we just saw that. So fancy. All right, create your box. There's 4 boxes within the big box. In the upper left-hand corner, you always put your leading term. So for us, it's x squared. In the bottom, you always put the last, so it's 30. These 2 squares, it doesn't matter what order you put them in, but it has to have the numbers that multiplied to the top and added to the bottom. Okay, now look at your rows. Negative 3x and 30, their greatest common factor. Take out that negative with it. X squared and negative 10x gave us the x. Your rows, x squared and negative 3x was x, and then negative 10x and 30 gives us a negative 10. So again, we have the same factors we had. It's just a different method to get it. It's equal to 0, so set them each equal to 0. And then solve. Make sure you write your answers together. Don't irritate me and write them separately. Okay, thanks. All right, last example. Example number 3. And I know I'm not slowing down, but you guys can always pause this and fast forward and do whatever you need to at that point. We've got 4x squared plus 7x. Oh, my husband's going to kill my little cat, you guys. Just kidding, but she might be homeless. Get away. Sorry. So notice your a value is not a 1 at this point. Okay, don't worry. The method's still the same. So we'll do the x factor. And in case you wonder, my little cat was trying to drink out of the water glass. We take a times c at the top. So that's 4 times 3, which is 12. The b is at the bottom, so that's 7. Again, same method, nothing changes. So what multiplies to 12 but adds to 7? You guessed it, 4 and 3. Plug them in for that middle term. So we get 4x squared plus 4x plus 3x plus 3 is equal to 0. At this point, factor by grouping. Greatest common factor for those first 2 terms gives you 4x, and you're left with x plus 1. Those second terms is a positive 3, and you're left with x plus 1 is equal to 0. Just like we had hoped, these are the same. So you pull that out and group what's left together. Now, if you're using this method and these 2 binomials are not the same, you did something wrong. Your arithmetic somewhere along the way is incorrect, so go back and double check. If you're using this method, those will always be the same. Okay, so x is -1 and -3/4. You can put it as a fraction or you can put it as a decimal. You know I don't care. All right, second method. Again, a times c at the top, which is 12. B at the bottom. Are we having fun yet? Oh, you know you are. And we know that 4 times 3 multiplies to 12 and adds to 7. All right, guys, make that box with the 4 squares. In the upper left-hand corner goes that first term for us. That was 4x squared. In the bottom right-hand corner goes that third term, so it's 3. These 2 boxes, again, it doesn't matter what order you put them in. You just have to put in 2 numbers that multiply to 12 and add to 7. Look at your columns. 4x and 3. They don't have a whole lot in common. They have nothing but 1. That's okay, so we'll put the 1. 4x squared and 3x, their greatest common factor is x. That's exciting. 4x squared and 4x, their greatest common factor is 4x. And then 3x and 3, their greatest common factor is a positive 3. So group your factors together. We get x plus 1 times 4x, pardon me, plus 3 is equal to 0. Set them both equal to 0 because of that 0 product property. If you multiply them together, they have to be, one of them has to be 0. So x is -1 and -3/4. Woohoo! All right, hopefully that was pretty easy for you to see. If you need to, you can always rewind and go back. At this point, you guys are going to go into your modules for Unit 2, and you're going to do that in-class factoring practice. Okay, remember, we've done stuff like this before. Make sure you have scratch paper out and you're working through it. I am, unfortunately, in meetings again today, but know that I'll be back on Monday. And have a great weekend. All right, bye, guys.